Yeah, welcome to RUG for August. Good to see a number of people already here. We've got a couple of people here in person, so we'll still be doing the hybrid split today. But for all those wanting to join in, if you want to follow along directly, you can go to the UQRUG website, which is on screen right now. Oh, hello, you made it. So for people in person, I will also get you to join into the Zoom chat. That way, if people have questions, you can share them. But the reason we try and use this computer is because that way we can have mics across the room. This computer is doing nothing at all. So in that case, we'll just take turns muting and unmuting. If you've got too many microphones on in the one room, it creates hassles. Yes, if you do want to get the link, if you go to uqrug.netlify.app, so that's UQRUG. That's right, you're on. That's good, cool. I will also put that in the chat. There we go. Yes, so this has links to things like the events that we have on, so you can see the previous events that we've done, as well as details about the past meetings. So if you go to the past meetings, this has the full kind of transcript of the different questions and answers that came up during the past meetings. Some other community groups that you can get associated with here around the UQ environment, as well as the upcoming ResBaz conference. But the other thing it gives you a link to is if you click the little document button up in the top right hand corner, it will take you through to the Edge doc. This is the interactive pad that I encourage. A new computer today, so I was saying I had some technical difficulties earlier today. Yes, the Hedge doc, I encourage you to go to that because this is where we can all sign in and put our questions for the day. So if you do want to get access to this, you can get through it via the Netlify link. I will also put a link to this directly into the chat on Zoom. Go. So if you navigate through the Hedge doc, yeah, you'll be able to add yourself to here. So welcome to UQRUG. UQRUG is a gathering for our users of all skills. Or maybe you've just got me on in the background while you're doing some coding. That's also totally fine. So as you know, we meet the last Wednesday of every month from 12 till 2. And we also have a link on the UQ chat page, which some questions do come through sometimes, which is cool. So in terms of the flow for today, we'll start by having everyone add their names to this page, which I'll show you how to do in just a moment. I'll get you to add your questions on this page. That way everyone can put their questions in and we have a bit of an order that we can go through to help people. We'll do our intro. And that this week is Valentina giving an intro to basic statistics. And then finally, once Valentina's done presenting, we'll go through answering the different questions that have come up. If someone posts a question, you can start answering that directly in the Hedge doc as well, if you'd like, and then we'll just read through that together. So how do you add your name to this page? Well, if you go through to the link that I've put in here, does everyone have access to that? Everyone here in person? So if you go to the UQRUG website, which is uqrug.netlify.app, there's a link to it in the top right hand corner. Karen, do you want to help them do that? Yeah, cool. Everyone in the Zoom to do it as well. Yep. So yeah, and you can get to the Zoom link as well through the Edge doc. Oh yeah, that's true. You can also just Google UQRUG, of course. Yeah. So if you click edit this note up in the top right-hand corner, there should be like a little pencil button. What I recommend is going to the split view, and this shows you the kind of the code that sits behind the way this looks. So what this is an example of Markdown. So Markdown is a very simple markup language that allows you to really quickly kind of have a very basic, easy to read standard text that you can also then use code to add formatting to. So if you add hashes, it makes it a title, multiple hashes make multiple titles. But what I want you to do is scroll down to the attendees section. And I can see that people have already started adding their names, which is awesome to see. People just going in autopilot here. I'm laughing at Car's bringing him here. Car has written in paste 0 rep learning 3 exclamation point, which for those who can't read the code would basically just say learning 3 times and then an exclamation point. So that's great to see, Car. Thank you. That's hilarious. Yep. So this is an example of a Markdown table where you've got these little bar symbols on the, if you press shift and then the backslash key is generally where it is. If you add your name, where you're from, and what brings you here there, you can be added to the table. And then I'll get you to add your questions down in the questions area. So we've already got a question here that I actually preceded earlier today. Because we had a question from Pradeepa who isn't here, but might be here. Might be here later. And I'll get you to just put in your question here and your name here, and then add some more detail, and then people can start typing in answers as they go. So don't be afraid to overwrite my template ones here. And yeah, just put all your questions in there. All right, while everyone's doing that, I'm just going to make sure everyone in the room is good to go. Alrighty, so I think it looks like everybody has added themselves in. So what we're going to do is we're going to go to Valentina now, who's going to give an overview of some basic statistics in R. It's going to get a little bit complicated in this room. So if my computer's the one that's not connecting that screen, can I get someone else's computer to do that? Yes. That way everyone on the screen can see. So I will stop sharing my screen and throw the sharing over to Valentina. So that for those who've just joined, please go through to the hedge.link link. I can just see some more people who just joined in. Go through that hedge.link link, click the edit button in the top right-hand corner, like the little pencil button. Change to the split view and scroll down and add your name, where you're from, and what you're here for.
Well, hello everyone. I am one of the technology trainers in the team, and right now I'm just gonna talk about very basic stats. Hopefully, what I'm gonna cover today is accessible, as in you'll find it not to be too extraterrestrial. And I'm just gonna get started. What you're gonna see today, me talking about, is like extra basic. Okay, there is no sophistication in what I'm gonna do about what I'm about to do just now whatsoever. So there are two. There is a package, let's say Tidyverse, that is already installed in my computer, and I am gonna load that library. And then there is Lattice, which is for making graphs in base R. So I guess in base R. So anyway, so I'm just gonna load those two libraries, and I also created 4 different data sets. When you're gonna be doing a statistical analysis on your data, what you are going to find is that the structure of your data matters, and there is not one size fits all kind of thing. We will intuitively normally think a long table is gonna be the preferred format in R, but turns out that if you are doing, for instance, correlations or regressions, it might want each variable to be on its own separate column. So what I have here, I have 4 different data sets. One is empty cars. I'm just gonna load them all. I'm calling them data 1, 2, 3, and 4. I'm just gonna create all of these ones in the environment and then explore them one by one. So I'm just going to run those. And I'm also going to create a couple of objects, X and Y, just because it is intuitive and easy when we put, for me, when I put arguments in a formula to call them X and Y. This is only going to be used for the first couple of exercises. So when you load your data, right now I'm using this type of reading CSV, but you could also be reading a text file if that's how if you have a tab space type of file, you can save that in your computer and also read it directly, or you can use other types of reading CSV depending on whether you're working with base R or with tidyverse stuff. All right, so to view your data, you could either click on any of the data sets or use the view function, and that will bring it up. The first data set, it's one that is built in with the tidyverse package. Oh, okay, there is a question in the chat about what's the difference between equals and with the assignment operator. When you use the assignment operator, you create an object in the environment. I have really never used the equal sign, but we have from CAR the description that they both do the creation of an object. This is new for me. Okay, good. And the best practice is to use the assignment operator. All right, so this is the motor type of the motor car data set is already part of the tidyverse. It's one of the data sets that come with tidyverse, and what is useful for is to practice it. From this data set, I'm only going to be playing with two variables at the moment. These two variables are going to be miles per gallon and weight, which is the weight of the car. Okay. All right. So let's view, when we're viewing the data, we could also have a look of the structure. So I'm gonna just run structure. It's always important when you load your data into R that you have a look of your, of the structure to see if everything loaded okay, and if your numbers are being read, like which type of variables you have and how they are being read, and also if all of your observations loaded. In this case, we only have 32 for this table, and yeah, it just loaded just fine. Okay, so let's have a quick look of the other ones. Data set 2, what it has is 2 times of the day. We have, let's say, morning represented by number 1 and afternoon represented by number 2, and time is reaction times of people that are, so we're basically the objective of this second data set is to compare reaction times morning and afternoon. Then the third type of data set, we have 3 modes of delivery of lectures. We have face-to-face, which we're calling the lecture, online, which we're calling, what via Zoom, let's say, and video, you record, and then the students pick it up and watch it. And we have how many students are using the different modes. And the fourth data set is conversion rates from Australian dollar to US dollar and from Australian dollar to euros. And we're going to use this fourth data set for the correlation. Nothing sophisticated, and I am sorry that I'm using 4 different ones, but I don't know. I'm just doing what I can here. And as long as it's useful for the demonstration, then it's good. All right. First thing that I have to say about statistics is, besides what I already said about the structure of your data, is you could run individually each of the functions like mean, median, and so on, or you can just run the summary data. And when you run summary data, you get a lot of statistics in there. what we're seeing reflected here is mean plus everything that you will see with the 5-number indicator or 5-number summary for each of the variables. But this one is being tasteful and calculating it for all the variables that I have in there. Another thing that is good to do when you have your data is create histograms and box plots of your data. Right now, I'm going to create it only for one variable using just the function histogram. And I'm putting y as my variable. And when I call my variable, what I am doing is talking about the data set name, and then $sign, and then the name of the variable. Okay, that's how it's defined. And that creates a histogram of frequency. I don't have magical eyes that are going to tell me whether or not this is a normal distribution, but it is important to at the very minimum start exploring your data before dipping into statistical tests. The second thing that I'm going to create for one variable, same variable, is a box plot. The most basic way in which you can create a box plot is this. And that way you have an idea of your distribution, your measure of central tendency, and so on. Always plot your data before running into inferential statistics and so on. And always have a look of your descriptive stats before also going into inferential statistics. All right. For inferential statistics, what I have today for you, it's only 2 tests, which, oh, wait, I guess this one also, well, this, yeah, I think this counts as well. Okay, so we have a 2-sample t-test, which we're gonna apply for this data set, which is morning and afternoon reaction times. And we are gonna see if the reaction times of people is different. I suppose I could create some box plots before. I don't know if I want to do that right now. Anyways, let's just roll with it. It's better if you create a couple of box plots and have some basis to even decide to run a t-test to begin with. So I run the t-test. I just put the 2 variables and the name of the data set, and it's just telling me a lot of things, including degrees of freedom, the t-statistic, and I guess what we all go for when we want to just quickly interpret the outcome of a t-test is the p-value. It's a very tiny p-value, which is telling us basically that the difference between reaction times in the morning and reactions time in the afternoon for these people that we work with is unlikely to be attributable to chance alone, because the p-value is super tiny. So there is a statistically significant difference between those two. Okay, so another analysis that we could do is an ANOVA. If we have something like multiple data sets, multiple things that we want to compare, okay? And multiple groups that we want to compare. And the ANOVA will tell us if there is a difference, but it will not tell us where the difference is. You'll have to do some digging to find out where the difference is likely to be. So the first thing that I'm going to do is plotting, which is actually what I recommend everyone to do first. And this is the plot that I'm getting for the 3 modes. So we have face-to-face, online, and video. And I'm wondering, is there a difference between these ones? So for that, you can run an ANOVA. Strictly speaking, this is the ANOVA. But if you just run that, maybe I should do that as well. If you just run that, it will give you this, and you may or not have all the information that you need. But if you want to see all the summary statistics, you put that, the ANOVA, the analysis of variance function, you put it inside the summary, and that way you will also get well, everything, so that you can interpret your your results. In this case, we don't have a statistically significant difference between those three groups. And normally before running a statistical test, it's important for you to establish your confidence level, so your alpha. Be clear about what your null hypothesis is. What is your alternative hypothesis? Are you doing a one-tail or a two-tail? Are you meeting your assumptions? What are the assumptions associated to your test? And I'm using a lot of words here, but what I am trying to do is recommend resources like this one. I'm going to just share in the chat. Sorry, I just noticed that there is a question in the chat. I'm going to answer in a second. Yes, not a problem. I'll share the transcript, not a problem. And I can share the data set as well, so you can play around with those. Okay, cool. So this link that I just shared, it's a very beautiful blog that I found. It has for a bunch of tests. It's very thorough. It introduces the type of test, talks about data, then A-mine hypothesis, then all the underlying assumptions on how you can test for some of those assumptions, preliminary analysis, how to run it, how to interpret it, etc. Okay, so this is a very beautiful resource, and I recommend that you find not just how to do the test, but also resources like this, so that there can be some so you can do your analysis in a thorough way, and you're aware of what you're doing when you're doing it. Okay, cool. So the last bit that I wanted to show you is the relationship between two variables. So for instance, we're going to use this data set with these two exchange rates from Australian dollars to US dollars and from Australian dollars to euros. So if I run this, which is just plotting it, we will see that it seems like there is a relationship between these two variables. Then what you could do is run a correlation. The function for correlation is COR. You just put data set, you call the variable, data set name, call the other variable, and then decide which method are you going to use. Are you going to use Pearson? Or are you going to use Spearman? Pearson is a parametric one. Spearman is a non-parametric one. Okay, the assumptions are different. This one assumes normality. This one doesn't. Again, I'm using a lot of words to say, make sure that you understand your data. Make sure that you have the correct volume of data to even reasonably assume things like normal distribution and so on. Okay, then you run it through method Pearson, and it will give us a number, which is the correlation. And that number is great. Okay, it's just telling us, yep, there is, this is the correlation coefficient, but that number alone means nothing. You have to then grab the tables, and you have to see what it tells you there is a strong correlation, but you could have a beautiful strong correlation with only three data points, okay? So significance and strength of the correlation are different things, and how useful your model is, that's another animal as well. So yeah, it's a little bit excessive if I try to explain all of that right now, but it's just a warning. Like, yes, you have a strong correlation, but then you have to go and read and interpret your result against the significance levels for correlation coefficients for Pearson or for Spearman. You can run Spearman. In this case, I don't think we need that, but that would be using a Spearman. And then if you want to do a linear regression, there is 1,000 billion ways in which you can do that. For instance, you could create like add a line in ggplot, like create this plot in ggplot, add a line, and then call for the formula. And then you get the formula in the console. Or you could, write linear model function on your two variables with your data, and it will tell you where it intercepts, which means where those the line that I'm not drawing, and I'm sorry about that, is cutting your y-axis, and plus the slope. So the formula would be FX, sorry, so the exchange rate for US dollar equal 1.6 times the exchange rate to euros plus as well minus 0.91. And that's your formula for the regression. So that's all I have for the basic stats. And I don't know, are there any questions? Is this roughly what you guys expected when you were asking for basic stats in R?
I think it's the sort of thing I expected. Seems like obviously there are so many different types of statistical analyses you can do and different ways to approach it. But this is just sort of like, I don't know, I feel like you've shown some of the really basic sort of ones, which is what we were asking for, like t-tests and ANOVAs and things. And then I really like the RStats thing that you've shared, the stats into R. It looks like if you go to that blog, they've got walkthroughs for all sorts of different types of statistical tests. So it seems like a really cool resource. So thank you for all of those.
Yeah, it's okay.
I did have a question, which was basically, could you briefly explain the kind of the way you set up the arguments in the ANOVA and the t-test? As in like you've got AOV and then students tilde mode data equals data. So is that like, which way around do you put students and mode? Because obviously data 3 is, this is where the data comes from. Students and mode are the two columns, but could you do mode then students?
Sorry?
So does it matter the order, which way around you put students and mode in that?
I'm not sure. Okay. I did this so many times, and many times it didn't work, but in many times it didn't work because my structure was wrong. So, but let's see, because maybe it doesn't matter. Maybe it does matter. Yep, it matters. So yeah, I guess you just have to put first the response variable, so to speak, and then put the grouping second.
Okay, cool. So one's the response and the predictor, and that's the order you put it in.
Yeah, yeah. So this is grouping and this is the value.
Yep. Cool. And was that the same with the t-test as well?
I think so, but I'm not sure. So we have time.
Reaction time and the time of day. Yeah, cool.
Yeah.
So one is the output and the other one is the thing that feeds into it.
The grouping, yeah. And in this case, the data is structured as a long table, but that's not what we have when we work with this. It actually did not work for the things that I tried. I could not get it to work when I had a long table. I had to actually like keep it as two separate columns for the correlation stuff. I hear a voice.
Someone asking if mode is numerical or categorical.
Mode is numerical or categorical? Mode is categorical.
Yeah. So maybe the t-test you could do the other way around. Because they're both numerical, so it doesn't know like with.
Oh, right. Yes.
Variable quantity.
So
you know what I mean?
Yes, the cameras point out if you swapped mode and students, it's going to break because one should be a numerical value, so students is, whereas mode being categorical, you can't swap it. Whereas you could swap the t-test values around and it would work, but it would be incorrectly working.
Maybe, yeah, not sure. Do you want me to try that?
I mean, it should run, but it should give you an incorrect result. It shouldn't give you an error.
Well,
I know grouping factor must have exactly 2 levels because there's too many different levels in time. So t-test is restricted. So cool. We have a couple questions appearing in the chat as well. Car has pointed out that the default t-test in R is Welch's t-test, which is more robust than a student t-test in assumption violation.
Okay.
Car has also asked, is the correlation function, COR, the R, and when you square it, it becomes R squared? So is the R
No, no. Sorry, no. Correlation, no, correlation coefficient in this case is Pearson, which is P. And R square is the coefficient of determination. It's conceptually, it's another thing. So
they use the same letter, but they mean different things.
no, they're different letters. Spearman is R, I think. No, Spearman, I don't know what Spearman is, sorry. But okay, sorry. So
That's
correlation coefficient that we calculated, this one is Pearson. Oh, sorry, this one is Pearson, P. The coefficient of determination, it's how good your model, your adjustment is. It's so it's calculated with this formula. Sorry. How can I zoom in? Sorry, guys.
Yeah, we can see that.
Okay, cool. Yeah, I just wanted to make it like larger. So that is R square. It's coefficient of determination, and it's just basically comparing. It's talking about how good your data, your line explains your data, so to speak. And it's just minus, so 1 minus this one divided by the, the squares of the distance. So it's comparing a line like this to a horizontal line. That's it. That's all that R square formula wise does. Coefficient of determination, which is different from correlation coefficient. Correlation coefficient, so Pearson, just it talks more about how one variable goes up as the other one goes up. If it is close to 1, oh, you're right. Look at that. It's an R. My bad. You're right. Sorry, Car. You are correct and I am wrong. I don't know why they use the same letter. I suppose one of them is capital and the other one isn't. So many letters in the alphabet and all the Greek alphabet, and they're gonna go and use the same letter. Nonsense. Anyway, so yeah, it goes from +1, 0, if one variable goes up and the other one just, sorry, one variable goes up and the other one is unaltered. And then we have a negative correlation, which is when you have like -1, which is as one variable goes up, the other one goes down. I walk more, my weight goes down. I eat more, my weight goes up. Kind of thing. I don't know. Oh, okay. Sorry. Does that help with your question, Car? Oh, okay, awesome. All right, and how do we graph multiple linear regression? I don't know. But I can say that I have seen that when you want to start adding more variables, you just go and plus. But this is with I think it's G. I don't really know. I think this is the name of the, what's it, G? Sorry, I don't remember what the formula, like the thing is, the formula. Jay, it's a good question. Can I owe you an answer? Or does anyone else in the room knows? multiple linear regression. Jay's question is, for multiple linear regression, how can we graph it? We might use ggplot, says Scar. Are you going to touch on ICC? ICC. I don't know what ICC stands for. Bernadette, are you okay to let us know what ICC means? And I am very sorry, I'm terrible with acronyms. I have no memory whatsoever. Interclass correlations. No, we're not touching interclass correlations. That sounds... No, I have no idea. Sorry, I don't cover that today. But if you need help with that because it's part of your analysis, you can send us an email and maybe we will be able to help out. Okay, so what I have seen for going back to Jay's question, I think it's generalized linear model GLM. Was I typing that the other way around? Sorry. Well, anyway, so what I know is that when you're using this generalized linear model, you can start adding more and more variables just using plus. And that way, it will just take into account the variables, all the variables that you have in your data set or whatever. And you can also make a choice about which one is the response variable, and you can go as far as using these when the response variable is a dichotomous type of variable. So if you have, let's say, on or off as your output. Yeah, I don't have an example today. And I'm probably not that good in improvising, so I'm probably not gonna try improvising right now. But I guess if you want to experiment with this with a safe data set, I would recommend GLM and then go for the motor car data set, because you also have things like these variables, which are dichotomous, or I don't know if I'm using the correct word, but you know, that you have, for instance, if it's automatic or manual type of car, it would be like 0 or 1. Of course, there is something funny about doing linear models with this because it's almost like we're predicting if it's going to be a manual or an automatic car based on characteristics that already exist, I guess, based on characteristics of the car. But anyways, it's an example, and it will maybe will allow us to, yeah, to make a multiple regression to see what, you know, how can we predict if it is automatic or manual based on the other variables, if that's a thing.
I might just jump in. I think Jay's question might be, so linear regression or multiple linear regression. Linear regression is just where you've got, you know, the one independent variable as the predictor. Whereas multiple linear regression is where you have multiple variables, the multiple independent variables as those predictors.
Oh, I don't understand. Can you say that again?
So linear regression is where you've got, you know, you've got the variables to predict your dependent variable.
Yeah.
And multiple linear regression is where you've just got multiple independent variables to then as predictors on that, or multiple variables predicting that. So the output should not be too, it should just still be a line, like a linear line on the graph. So you shouldn't need to plot that differently to how you would with any other regression.
Okay. It's like just, so what Jay is talking about is just how to do a bunch of linear regressions for different data on their, like on their own, but all represented on the same plot, like what Car just shared, like this. This. So in this case, they have two variables, A and B, and just do those like two regressions and represent them in the same plot. Is that
I think that's what Jay was asking.
Jay,
So
are you?
Those are two separate linear models representing the two different potential outputs, but they'd be built on different.
Yeah. Sorry, okay. Yeah, no, sorry, I completely missed the ball. I thought that she was talking about like combining different variables in one linear model. Okay. Okay, cool. Thank you for helping with that. I had no idea.
All right. Do we want to throw to the general questions now? Do you have anything else for us today, Valentina?
No, that was it. I was expecting it to be 10 minutes. Sorry, guys.
Totally always happens. So Jay's just got to follow up multiple answer, multiple linear regression. So multiple linear regression is where you've got multiple variables going in to predict the output. So it should still just be one line as the output, unless you're trying to plot different potential outputs. So it should still just be one line, unless you are wanting to predict for two different types of output. I'll try and get an image just to show the difference between.
Yes, I'll stop sharing. I am very sorry. This is out of my depth. I'm not familiar with that terminology.
So like the only difference between like linear regression and multiple linear regression is that you've got multiple estimated slope coefficients. So you've got multiple independent variables coming in to determine that slope. So it should still just be one line in the output. It's just a more complicated equation that goes into calculating it.
Is that a bunch of the same equation? Just straight lines? No?
But I might come back to that at the end. So we'll jump back through to. Yeah, we might come back to linear regression at the end, but we'll jump through to the questions in the hedge doc. So yeah, if you could throw your question into the hedge doc, Jay, just it's turned into more of an in-depth question. I'll take back and share the hedge doc, and we'll go through the order of which people have asked the questions.
And Ryan, would you be okay to put your question in there? So I suppose, or I don't know, it's Nick, do you know about plots in 3D? This is again like not something I know about. Oh, sorry. Oh, you were trying to sorry. Okay, then we have that still as a possible question a possible answer to explore when we get to Jay's question. Thank you so much, Nick. I'm gonna change locations now.
No worries. Thank you, Valentina.